Hello everyone. In this video, we'll talk about law of total probability and Bayes theorem. So let's see one problem. A box contains 4 red and 3 black balls. A second box contains 2 red and 4 black balls. One box is selected, one ball is drawn. Find the probability that the ball drawn is red. So we have such kind of situation. We have two boxes. One box contains 4 red and 3 black balls. The second box contains 2 red and 4 black balls. One box is selected. So either the first box will be selected or the second box will be selected. So the probability of selecting first box will be 1 by 2 and the probability of selecting second box will be 1 by 2. So the situation will be something like this. And then after selecting one box, after selecting either first box or second box, we have to choose one ball. Okay, and we have to find the probability that the ball drawn is red. So if first box is drawn, then what will be the probability, conditional probability of a red ball? Why it will be conditional? Because we have already choose the first box and then we have to choose the second we have to choose the red ball. So it is conditional probability. First event has already occurred, then we have to choose the second we have to choose for the second event, that is the red ball. So for this it will be 4 by 7 because there are total 7 balls here and 4 are red, so 4 by 7. Similarly, for this one also, it will be 2 by 6. There are 6 total balls and 2 are red, so 2 by 6. So the situation will be something like this. We have two boxes. Either first box will be chosen or the second box will be chosen. Then red ball, if first box is chosen, red ball can be chosen 4 upon 7. The probability of red ball will be 4 upon 7. And if the second box is chosen, then probability of red ball is 2 upon 6. So now the total probability of drawing the red ball in such kind of situation is 1 by 2 multiplied by 4 by 7 plus 1 by 2 multiplied by 2 by 6. Okay, because either this thing will happen or this thing will happen. So for or case we have plus. This thing will happen and then this thing will happen. So it's multiplication here. Or second box is chosen and red ball is drawn, so multiplication is there. So total probability of red ball is given by this formula. You multiply these two and then multiply these two. So this is the probability of finding a red ball. This is a particular case of total law of probability in which only two events were there, only two boxes were there, two events were there, right? We can look at this situation in terms of events like this. If you have two events and event A occurs after happening of these two events, then by total law of probability occurrence of event A, probability of occurrence of event A is probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. So if we have n events, E1, E2, E3, so on, En minus 1 to En, and event A occurs after happening of these E1, E2, En events. So this formula is for the total law of probability for n events. So let's see one more example. In a bowl factory, machine A, B and C manufacture respectively 25%, 35% and 40% of the total bowls. Of their output, 5, 4 and 2% are respectively defective bowls. A bolt is drawn at random. Find the probability that bowl drawn is defective. So we have here, let's take E1 to be the bowl manufactured by machine A. Let's take event E2 to be bowl manufactured by machine B, and let's take event E3 to be bold manufactured by machine C, and let's take event A to be a defective bold. Now we have to find out probability of a defective bold. Okay, we have to find the probability of event A, and event A is occurring after these three events. What is the probability of E1? Probability of E1, bold manufactured by machine A, and machine A is manufacturing 25%, so 25 upon 100. Probability of E2, 35 upon 100, and probability of E3 is 40 upon 100. What is probability of A upon E1? Event A is defective bold. Okay, so defective bold manufactured by machine A is 5 upon 100. Defective bold manufactured by machine B is 4 upon 100, and defective bold manufactured by machine C is 2 upon 100. So we need to find probability of A by total law of probability. We have probability of A equal to this formula, probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2 plus probability of E3 into probability of A given E3. So we will substitute all these values here. Probability of E1 25 by 100, A upon E1 5 upon 100 plus probability of E2 35 upon 100 into probability of A given E2 4 upon 100 plus probability of E3 40 upon 100 into probability of A given E3 2 upon 100. After solving this, we'll get 0.0345 as our answer. So this is the probability of getting a defective bolt. So this is how we use total law of probability in solving such kind of problems. Let's just look at a problem which is similar to our previous problem. In a bowl factory, same problem. A, B, C are three machines, and they are respectively manufacturing 25%, 35% and 40% of total bowls. Okay, and 5, 4 and 2% are respectively defective bowls among them. A bolt is drawn from random and it is found to be defective. We have to find the probability that it is manufactured by machine B. In previous question, we were finding the probability of defective bolt. In this question, we have to find the probability that defective bolt is manufactured by machine B. So it's one further step to the previous one. So here let's take E1 to be bolt manufactured by machine A, E to be bolt manufactured by machine B, and E3 to be bolt manufactured by machine C, and let's take A to be our defective bolts. And what we need to find out? We need to find out the probability that it is manufactured by machine B. Okay, we have already taken out a defective bolt. We have to see that it is manufactured by machine B. So we need to find out probability of E2 given A, conditional probability that the bolt is manufactured by machine B, provided that it is a defective bolt. So we need to find out probability of E2 given A. So we have these things with us. We have probability of E1 25 upon 100, probability of E2 35 upon 100, probability of E3 40 upon 100, probability of A given E1 5 upon 100, A given E2 4 upon 100, and A given E3 2 upon 100, and we need to find out probability of E2 given A. That probability that we have taken out a defective bolt and that defective bolt is manufactured by machine B. So probability of E2 given A is given by this formula, by our formula on conditional probability. Probability of E2 given A is equal to E2 intersection A upon probability of A. You can watch my previous video on conditional probability to know about this formula of conditional probability. And what is probability of E2 intersection A? E2 intersection A is probability of E2 into probability of A given E2. Okay, and what is probability of A? By law of total probability, probability of A is equal to this sum. Okay, so we know all these values. We can put all these values here in this formula. What is probability of E2? 35 upon 100. Probability of A given E2, 4 upon 100, we'll put it here. Probability of E1, 25 upon 100. Probability of A given E1 is 5 upon 100, we'll put it here. Probability of E2 is 35 upon 100, we'll put it here. Probability of A given E2, 4 upon 100, we'll put it here. Plus probability of E3, 40 upon 100, we'll put it here, into probability of A given E3, 2 upon 100, we'll put it here. After solving it, we'll get 28 upon 69 as our answer. So 28 upon 69 is the probability of getting a defective bowl manufactured by machine B. So this is what Bayes theorem gives us. Bayes theorem gives us the probability of event E1 or any En such that event A has already occurred. So if S is a sample space and E1, E2, En are n mutually exclusive and exhaustive events associated with the random experiment, and if A is any event which occurs with E1 or E2 or En, then probability of Ei given A is equal to this formula, and this is the formula of Bayes theorem. It always gives us the conditional probability of event Ei given A has already occurred. So this is the Bayes theorem. So let's do one more example related to Bayes theorem. There are 3 bags, each containing 5 white and 3 black balls. Also there are 2 bags, each containing 2 white and 4 black balls. A white ball is drawn at random. Find the probability that this white ball is from a bag of first group. So here we have 2 groups. Okay, the first group of bags has 3 bags, each containing 5 white and 3 black balls. Second group of bags contain 2 bags, each containing 2 white and 4 black balls. A white ball is drawn at random, and you have to find out the white ball is drawn from the first group. So here Bayes theorem will be applied. Let E1 be the event of selecting the first group, and E2 be selecting bag from the second group, and let A be the ball drawn is white. So what we need to find out? We need to find out the probability that it is white ball from a bag of first group. So we need to find probability of E1 given A. Let's see what all we have with us. What will be the probability of E1? Probability of E1 is selecting bag from first group. Okay, so in first group we have 3 bags, and in second group we have 2 bags. So total number of bags are 5. So probability of E1 will be 3 upon 5 because there are 3 bags in the first group. Okay, similarly probability of E2 will be 2 upon 5 because there are 2 bags in the second group. Okay, now what will the probability of A upon E1? That is probability of selecting a white ball when we have already choose the first group of bags. Okay, so white balls, how many white balls are here? 5 white balls are here, and total number of balls are 8. So it will be 5 upon 8. And probability of A upon E2 will be 2 upon 6, which is 1 by 3. Okay, so these are the things which we have with us. Now probability of E1 given A, because we have to find out that probability that is a white ball and drawn from the first group. So for the first group it is E1, so we need to find out probability of E1 given A, that it is the white ball. So by Bayes theorem it is given by this formula. Probability of E1 given A is equal to probability of E1 into probability of A given E1 divided by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. So let's put all these values here in this formula. What is E1? Probability of E1 3 upon 5. Probability of A given E1 5 upon 8 whole divided by probability of E1 3 upon 5 into probability of A given E1 5 upon 8 plus probability of E2 2 upon 5 into probability of A given E2 1 upon 3. So after solving it we'll get 45 upon 61 as our answer. Thanks for watching this video. If you have any query you can ask me. Thank you. Have a good day.